This is for Year 12 Specialists. It comes out of question number 8 in 6E to do with points of inflection, second derivatives and curve ups. Okay, so we have a local minimum at x equals a and no other stationary point close by to a. So to help demonstrate this, I've drawn 3 separate examples. At a, there's a local minimum on this parabola. At a, there's a local minimum on this cubic, and at a, there's a local minimum on this quartic. The first derivative will be this straight line with a cutting the x-axis at a parabola cutting the x-axis at a, and this cubic cutting the x-axis at a. And then the second derivative, this straight line will be a positive gradient, so it's up there. This straight line will be negative 0 then positive, so it's going to be up there, and the same with this parabola. So what questions do we have in question number 8? For small values of h, that is very close, what is the value of the derivative just to the left? And just to the left, the value of the derivative will be negative. Just to the left, the value of the derivative will be negative, so it has to be value negative. At a, it's all equal to 0 because it's a stationary point, and the other side of a, it's going to be positive, therefore it's going to be greater than 0. What can be said about the gradient of f dash of x? That is the value of the second derivative during the interval from just to the left of a, just to the right of a. So the second derivative will be, it's going to be positive. Either side of a, it's going to be positive. Either side of a, it's going to be positive. So I can say that it's going to be bigger than 0. What can be said about the derivative, second derivative at the value of a? It's going to be positive, it's going to be positive, it's going to be positive. So it's going to be greater than 0. Verify your observations by calculating the value of the derivative of each of these. Okay, so if f of x equals 2x, x squared, f dash equals 2x, f dash dash of x equals 2, therefore f dash dash of 0 equals 2. If f dash of x equals negative cos of x, then f dash equals the sine of x, therefore f dash dash equals the cos of x, and cos of 0 equals 1. And lastly, f dash of x equals 4x cubed, f dash dash of x equals 12x squared, and f dash dash of 0 equals 0. So when we have turning points, it could be positive or it could be 0, is what we can say. Can the second derivative at a local minimum ever be less than 0? No, it can never be less than 0. And I can confirm that by looking at this little table, that if I have a local minimum, that means that the first derivative equals 0 and the second derivative must be positive. Therefore, no, you can't in that particular case.